Hello, and welcome to the section part of our exponential functions section. Today, this is probably going to be many of your favorite section because we get to look at graphing exponential functions. So let's go ahead and start out by looking at what a exponential function graph should kind of look like. Here you can see that we have two different graphs of exponential functions. Now, exponential functions, like in the case of the first graph here on the left, if I look at this red line, this red curve here is of the graph y equals 3/2 to the power of x. To where the blue line that curves downward, this is the y equals a negative 3/2 to the power of x. So typically we would only be looking at one of these, and if it's a positive value, then it's going to be curving upwards. A lot of times these are associated with something like exponential growth, because you can see that it starts out kind of growing slowly, and then as it increases, it's going to increase at a faster and faster rate. Now if we put that negative in the front, just like when we saw linear functions, if you have a negative in the front, that's actually going to reflect that, in this case, over the x-axis, which will give us this blue curve that we've got going on here. The other thing I'd like to point out on this graph here on the left is notice that both of our, what we would normally call our b values, because remember, an exponential function has the form y equals a times b to the power of x. Okay, so we don't have an a value, we just assume that to be 1 here, but we do have this b value. Now 3/2 is actually a number that is greater than 1. So because our b is greater than 1, this is going to give us that curve that is kind of increasing as it goes from left to right, or our growth type of curve. If you look over to the graphs here on the right hand side, this pink graph has a downward curvature to it. Okay, and that's because when we look at that same b value, notice that we now have a number that is less than 1 but greater than 0. So once you get that number that's less than 1 and greater than 0, as we have here, we kind of get this downward curve, and we would say that this is like something that is exponentially decreasing. Okay, likewise this blue curve on the right, okay, it's a reflection of the pink one here over the x-axis because we have that negative symbol in the front. One last thing I would like to point out, okay, is if you look at the y-intercepts, okay, and let's just look at the two pink graphs for now. Notice that both of these go through the coordinate point 0, 1. That's because if we were to rewrite this pink equation as a y equals a times b to the x, we really have y equals 1 times our 3/2 raised to the power of x. That point of intersection on the y-axis, okay, right here, is actually coming from the fact of our a value, okay, or coming from that point there. So this will give us our y-intercept on any graph, and you'll see this later on. If we have to make our own graphs, the way we're going to make our graphs is we are going to create a table, come up with a few x values. Typically I like to make them nice and easy, maybe a few points before 0, 0, and a few points after 0. Then we're going to come and join the points with a smooth curve. So let's look at a couple examples and then we'll wrap up part 2. So if we look at example 4, this says to graph the equation y equals 3 times 2 to the power of x. And as I just mentioned in the previous slide, we're not given any values here to graph, we're just told to graph this function. So what I'm going to do is I'm going to just pick a few points, and again, I like to pick a few negative numbers, 0, and a few positive numbers just to see how this graph is going to behave. So if I pick points that make it easy on myself, I'll go -2, -1, 0, 0, 1, and a +2. Next, I'm going to go ahead and fill in my y column by plugging in the x values that I just created. Okay, so if I plug in -2, I have 2 to the -2nd, which is actually going to give me 1 over 2 squared, or 1/4, and I'm going to multiply that by 3, so I end up with a positive 3/4. If I plug in -1 in for x, That gives me 2 to the negative first, or 1 over 2. And then I'm going to multiply that by 3. So 3 times 1/2 will give me 3/2, or 1.5. If I plug a 0 in for x, I end up with 2 to the 0, which is 1, times 3 will give me 3. If I plug a 1 in for x, that's 2. Then I have 3 times 2, which is 6. And if I plug a 2 in for x, I end up with 2 squared, which is 4, times 3 will give me 12. Now I've got 5 points that I can go ahead and plot on my graph, which I'll go ahead and do right now. So here are my lovely points with the stylus that I'm using. And then what I'm going to do is I'm going to go ahead and connect these points with a smooth line. And you can see that you get something that looks like an exponential curve. Hopefully on your piece of paper it goes a little bit better than it does on the iPad. But you'll notice that because I do have an a value in my function, which is 3 in this case, my y-intercept is actually at the point 0, 3. I have an upward curvature, which tells me that I had a number or a b value that was greater than 1. And I could say that this has some type of an exponential growth to it. Example 5 is similar to example 4. I'm going to pick the same values to start out with. Again, those are kind of my favorite numbers to use. You can pick something different, but I would at least recommend that you pick a few negatives, zeros, and a few positives. Then I'm going to go ahead and plug each one of these x values in for x into my equation and solve. Then I'm going to create a graph, and because it looks like my y values are pretty small, I'm probably going to go every 4 spots, or every 4 grid marks is going to be 1. So I'm going to sketch that out real quick. We're going to end up with something that kind of looks like this. Now I'm going to go ahead and plot my points. And again, the numbers are kind of small, and that's okay, so just kind of approximate the best that you can. Here you can see that I've plotted these 5 points out. Okay, again, if we just kind of keep note of the important parts, okay, 1, my graph does have kind of an upward curvature, and it should because my base number of b is a 2, which is greater than 1, so that tells me it's growing. Okay, my a value is 1/2, which is going to correspond to my graph as the y-intercept, which is right here. And remember, I'm going up by units of, like, every 4 tick marks is 1, so that tells me every grid line then is 1/4. So I'd have to go 2 grid lines up to get 1/2. Okay, so that seems to fall into place. So now I'm just going to connect these points. And you can see that we get a curve that looks like it has some type of exponential growth to it. For our last example, in part 2, we have a similar function, except now it's y equals a negative 1/2 times 2 to the power of x. Okay, looking at this function right away, okay, I can tell that it's going to have some type of an exponential growth. However, this negative a value tells me it is going to be reflected over the x-axis. So although it's a growth function, it's going to be facing the downward direction. And I'll show you what I mean as we plot this. I'm going to set up my table with the same values of -2, -1, 0, 1, and 2. And then I'm going to go ahead and fill in my y column by plugging those points in. So I'll go ahead and do that here real quick. Okay, now I have my table set up. My graph is all labeled, and I'm going to go ahead and plot my points now. So as you can see, our points look similar to the graph that we just created in example 6, except they're going in the downward direction here because we are reflected over that x-axis due to this negative a value. So the last thing I'm going to do is just connect my points with a smooth curve, and we can wrap up example 6. Please let me know if you have any questions. This will now allow you to do part 2 of your homework. Have a good day.